Okay, this side you see the spermatogenesis. So spermatogenesis will start from a stem cell, which is the spermatogonium. Spermatogonium goes under the mitotic division and makes the primary spermatocytes. And the primary spermatocyte goes under the first meiotic division. And here you see the first meiotic division in primary spermatocyte, which is the anaphase, anaphase 1 in primary spermatocyte. After finishing the meiotic 1, primary spermatocyte gives two secondary spermatocytes, secondary spermatocytes. Here you see again the anaphase 2 in one of these secondary spermatocytes. After finishing the second meiotic division in these two secondary spermatocytes, there are 4 spermatids. And these spermatids are haploid cells and contain 23 single chromosomes. Then, after these spermatids, spermatids go under the spermiogenesis and change their shape, and they make sperm. So each spermatid makes one sperm, and each sperm has one head, one middle piece, and one tail. Now these sperms can move and go outside of the testes. For this side is the oogenesis, or making ovum in female reproductive system inside of the ovary. Again, a stem cell in female is called oogonia. Oogonia. Oogonia goes under the mitotic division and gives the primary oocyte. Then this primary oocyte goes under the first meiotic division, and after finishing the meiotic division, it gives one secondary oocyte and one polar body. This polar body is called first polar body. So this is before completely division of the first meiotic division. This is the anaphase 1. Then this secondary oocyte goes under the second meiotic division. After the second meiotic division, you see that this polar body gives two polar bodies, second polar bodies, and this secondary oocyte gives another polar body over here and one ovum. So here it shows you one ovum, which is the mature cell, and it has 23 single chromosomes. So these three polar bodies will degenerate. Just this mature ovum will remain over here. And here you see the fertilization. The head of sperms, one sperm went in, and the chromosomes of the head of these sperms will combine with the chromosomes of the mature ovum, and they make zygote. So you see the other sperms which are remain at the outer part of the ovum. So when one sperm went in, the other one cannot go in anymore. So this is the fertilization and zygote.
So once this one goes in, it inactivates the whole membrane, so that kills everybody off from going in after that.
Doesn't kill
Well,
it.
you know what I mean. He was the lucky one that got
but
in.
they will die.
Yeah, they will die off.
Yes, they will die
Later.
because
It's all about speed.
because
Yes.
these sperms
should
that
have an
are
experiment.
located around of here, they release their enzymes at the same time from their acrosome. So that's why they have to be here to help this one to go in.
Oh, okay. So without these two here, he wouldn't have made it.
No, one is not enough.
Teamwork.
So it's like a whole cluster has to attack. And
Yes, they help each other, but just one
one
of them
is fortunate
can win
enough
the
to
game.
make it. Oh.
I got you.
Yeah,
your
you
back.
got that right.
So this is primary oocyte, this is secondary, right?
Yes.
And this is secondary? Sir?
Yes, this is the secondary during the second division, and this is
So
the
this is-
mature ovum.
Okay, this is anaphase 2,
Yes, anaphase 2.
anaphase 1,
Mm-hmm.
and metaphase.
This one?
Two
May
and one.
total. May
This is
total
the-
division.
From
Everything.
And these are the
So metaphase 2?
Mhm.
There is no metaphase 1 here.
No. No, this is the
Natusan ko
metaphase
siya.
1. Metaphase 1, anaphase 1,
Sabi ko pa
then
ang video.
anaphase 2.
So no metaphase 2.
No, there is no metaphase 2.
Ano to?
This is the model for showing the meiotic division. This cell is the cell that has the chromosomes inside it. This is the first stage of prophase 1. The middle and late stage of prophase 1, you see the formation of tetrads and the homologous chromosomes located next to each other. And then they can exchange their genes as well at this time. Then this is the metaphase 1. Anaphase 1, that the homologous chromosomes go to the opposite poles. At the end of the first meiotic division, there are 2 cells that contain 23 double chromosomes. So these 2 can be considered as prophase 2 as well. So these are the prophase 2 for second meiotic division, metaphase 2 for second meiotic division, anaphase 2 for second meiotic division. In anaphase 2, you see that each chromatid for these homologous chromosomes will separate and go to the opposite poles. And at the end of the second meiotic division, there are 4 cells, and these cells are haploid cells because they contain 23 single chromosomes.
Okay. Thank you.
Yeah.
Yan. Nalobat na ako. Ay!
Sorry.
Okay lang, kuya. Facebook People. I know. Inutusan ko siya. Friends kami, ano. Video kaya to. Oh. Wala kang video, yung picture lang to.
Put that on YouTube so we
Huh?
can see.
Yeah, I am putting everything on YouTube.
Are you?
Yeah.
How do you research?
How do we?
Bigay ko channel ko. Teka. Hold on. Clarky. Oh, Facebook nga. Hindi. Ito.